Yep. So we started recording. Yeah, again, this is Probabilistic Programming 1. So just like Bert's lectures, so we have a set of lecture notes. That's a more or less practical session. Normally we would do this together in a classroom somewhere. Then we would put up the notebook. Each of you could try all of the cells, and then we would walk around and see if we can help people if they get stuck on certain things. So considering everything is virtual now, we have to do this differently. The lecture notes are online. I hope you've all seen them. I put 3 videos online where I discussed the main points from that lecture notes: model specification, parameter estimation, and model evaluation. I hope all of you have had a chance to look at these videos. And today this lecture is to discuss certain parts of the lecture that have not been clear. So I will also keep Piazza open to have a look at what everyone is saying. I noticed yesterday that the most questions on Piazza come from people that have trouble getting Julia and Jupyter started on their own machines. So we do have backup solutions for all of this. So we try to help everyone to get it started on their own. Most of the stack traces that have been posted on Piazza I've never seen before. So it's normally we would walk around and try to figure out on your own machine what is happening, but we can't do that now. So we're trying to from the stack trace you've posted on Piazza, we're trying to figure out what went wrong. If you post something and there's a response to it and we ask you to do something, then please try that out for us. And we don't know the answer to your error, right? We have to figure that out together. There is a backup solution. If you go to, I'll share my screen. So this is something that was also listed in the installation guide for the Windows operating system. There is something called VirtualBox that allows you to emulate a certain operating system on your own machine. So if you're on macOS or on Windows and you're having trouble getting Julia Jupyter started, and we can't figure out remotely what is going on your machine, you can download VirtualBox. There's instructions for how to run that on your specific flavor of OS. And that allows you to set up an Ubuntu environment on your machine. That'll be an up-to-date, clean Linux environment. And then you can follow, within that environment, you can follow the installation steps for the Ubuntu OS. On Ubuntu, all of this is much easier. Most of the commands are one-liners, and then everything runs smoothly. So that's sort of a backup solution to try. The disadvantage is that you would have to boot up VirtualBox every time you want to do something for the course, and then after you're done with the course, it's still sort of located within this separate part on your machine. So that's still an option. Other than that, today we are discussing parts of the first lectures on probabilistic programming that you found difficult or confusing. So please let me know which parts you want me to review, and we can go over that in a bit more detail right now. So Hoifung, am I saying your name right, Hoifung? You're asking if Colab is also an option? Okay, yeah. So I'm guessing you mean Google's Colab. I was under the impression that Colab does have a Julia kernel these days. Although I have not tested this. Okay, so maybe I read it somewhere that it's an upcoming feature of Collab that you're allowed to put in other kernels. Because at the moment I can't see anything but Python kernels. Yeah, so I don't think Collab's an option this year, maybe next year. Yeah, so Magnus also says it is possible to run Julia in Collab, however it requires setting up Julia manually. Yeah, so you're going to run into the same problems that you're experiencing now if you having troubles with the Julia kernel. Are there any questions on the notebook? Did everyone complete it? So there's a couple of points in the notebook where there's a try for yourself. So normally we do this interactively. So you walk around in class and you could we could advise you on how to run certain cells on your own machine. All right, so David says that the Windows install worked perfectly. Okay, that's good to hear. Yeah, that's good to hear. Yeah, so if there's any questions, let me know. I might spend 10 minutes just going over a few things in the notebook you could try for yourself. But yeah, let me know if you run into any problems with the notebook. So well, in this notebook, we're doing an experiment. It's based off of a classic experiment called the lady tasting tea, but now we're doing it in a modern variant with beer tasting. It's real data. This experiment actually happened, and so the point is, the lecture is not introducing anything new. It's all stuff that Bert has said before. But the theory lectures can be a bit abstract sometimes. You'll see a lot of P's and P's of theta, so given X or X given theta. And the hope is that if we tie this to an involved example, such as beer tasting, that some of these concepts become a bit more intuitive or a bit less abstract. Yeah, so in the first part on model specification, so model specification about a likelihood and a prior. The likelihood here is a Bernoulli distribution, so the coin toss example. But now it's about participants that come by and they have to correct which cup contained alcohol. So, and that event, whether they guessed it correctly or not, is expressed as this variable x. So we go over the Bernoulli distribution here a bit, in particular its shape, and we go over the notion of a likelihood function, namely that it is a function that tells you how likely a particular parameter is given your observed data. Then we go over the prior distribution. In this case, we'll use a beta distribution for the prior on the probability of guessing it correct. So the most valuable part of this session is that you get a chance to play around with these parameters. So I place code notes throughout the notebook. Can everyone can you let me know whether you have experience with MATLAB and Python? So if you've worked with Python before, could you just type yes in chat? Okay, that's right. Okay, that's good to know. Yeah. Right. So most of the syntax from Julia is actually quite similar to Python, but there's a few differences. And most of the code nodes that are on the cells, they just relate to the differences between Python or MATLAB sometimes. So have these been useful? Is it hard to grasp the code? Is it hard to read the code you see in this notebook? Do you think we should do more to elaborate the differences? Okay, so I have 3 people saying it's clear. Shibai says for now it's clear. It's going to get a bit more difficult, but we'll try to ramp it up at a steady pace. We won't go in an exponential curve. Tim says it's easy to read, just a special case with the dots can confuse me. Okay, so this is a perfect question for this session because I can show you a bit what those dots mean. Right, so there's this concept called broadcasting. So whenever you, that's not one of the issues with the Julia programming language is that when you Google Julia something, you're going to get pictures of Julia Roberts and more famous Julias. Right. So normally, if you have a vector. Let me see. So if I have some vector, 1, 2, 3, in this case a column vector. Hi, Bram. Do you want to ask a question?
Yes, actually. Sorry.
No worries.
I have installed Jupyter and Julia and everything, and I think I did everything correctly.
Yeah.
However, it still doesn't run. When I click run all, it just doesn't really do anything. So
at all? It doesn't report anything either.
Yeah, it doesn't report anything. So I'm not sure where the problem is, where I should look. I don't know if you experienced something like that before.
Could you post a screenshot of your, so before you press run all, post a screenshot of your notebook to Piazza? So there's on the top right corner here, there's the kernel specification. So in every notebook, there's a chance to, it tells you right there what the current kernel is on. And so you can change kernels a bit as well. So if you post a screenshot of, or maybe you can tell me right now what kernel version
this is like before this I installed the wrong kernel that was 1.3 and now I switched to 1.5.3.
Yeah.
Yeah.
Do you see a circle there or is there a bomb? There's sometimes a bomb icon. That means it died.
It's just a circle.
Okay. So, okay, and when you have a, so are you running Windows or something else?
Yeah.
Windows. Okay, so when you have an Anaconda prompt open, when you call Jupyter, it gives you a lot of feedback that scrolls down, right? Is there anything in particular, something yellow or red in that trace?
No, it's also just black and white. I think that's our the only colors.
Okay, could you when you install Julia 1.5.3, did you remember to do install kernel? So if you open Julia, do using iJulia and then install kernel Julia?
Yeah, if that was in the PDF, I think I did it.
Yeah. Okay. So if you open a notebook, it does say Julia 1.5.3 in the top right corner. That means that the Julia kernel has been installed, and Jupyter should be able to use that kernel. But if Jupyter doesn't respond to your command to run all, that means I'm thinking that means it has trouble finding the kernel. So there's a command called, I posted that in Piazza yesterday. There's a command called Jupyter kernel spec and then remove. And you can remove both the 1.3 and the 1.5 kernel. And yeah, try to remove both and then reinstall the kernel and then see if it responds to run all. I've never had that. I've never encountered that before. That just doesn't do anything when you press run all.
Okay, then I will try that.
If that doesn't work,
Piazza, right?
yeah, you just post it to Piazza. Yeah, and maybe so Magnus is also listening at the moment. Maybe you can Google this error. It's either that Jupyter can't find Julia, or that there's something wrong with Jupyter itself. Yeah, or shoot Magnus a message. Yeah.
Okay, thank you. I will try it.
Hi, I've got a question about the beta distribution.
Yeah.
Why do we use the beta distribution more exactly? Do we use it because we also use the Bernoulli distribution, and when we multiply them, they are similar to a beta, or which is the reason more exactly we choose these distributions?
Yeah, so the main reason at this point is because they're conjugate, and Bert will get more into this concept a bit later. So that if you use a beta prior, you're going to get a beta posterior. This just makes computation easy, and you see that there's this updating of belief, updating of knowledge after you've observed data. So we use it because it very clearly describes this concept of I have some prior belief about how well I think people can discriminate beer. Then I observe data, and then there's some posterior belief, and that posterior belief is sharper and is focused towards a particular value. And that if you want to use a point estimator, such as an expected value or a map estimator, it gives you point plus its uncertainty. Later, you can technically use any prior that has support in the range of the parameter. So the Bernoulli distribution, its rate parameter is defined from 0 to 1. And any distribution that has support there in that range could be used. If you use something like a Gaussian in the range, things do become difficult. So you have to use a lot of approximations for the posterior, which we don't really go into here. But yeah, you can use distributions that have, you can use other distributions that are supported there. But we are using the beta for that purpose.
And just out of curiosity, you said that because they're conjugated, it's easier to calculate. But how would this translate to Python? Is it easier for the programming language in what way? Less computation time, or?
Well, in general, so what we're doing here is not Julia specific. So we're doing probabilistic programming. Probabilistic programming is a particular subfield that is arising right now. Every programming language has some probabilistic programming software package. And all of those packages just implement the theory that Bert tells you about, that Bert lectures you on. So in Python, there are also probabilistic programming languages, and they also implement the math that Bert tells you to do. It's not Julia specific. So Python also has packages where you have a model description with some X that is, so this tilde mark, and then some distribution, in this case Bernoulli, and then there's some theta, and then there's a tilde, and then there's a beta distribution. The field is converging towards a standard model description language. I can give you some examples for probabilistic programming packages in Python or some of the other languages if you want.
Thank you for your answer.
Yeah, okay.
And maybe a bit out of curiosity. So during university, we mostly use MATLAB.
Yeah.
And I was curious if all the things we do in here are also doable in MATLAB.
Well, the math is, yeah, there's no problem with getting the math installed, except that, so if you want to make use of a software package where it's fairly straightforward to, I mean, you get to call certain distributions. I mean, this notebook does not contain the software package that we in our lab developed called Fornilab. And in Fornilab, you'll see that a lot more complex models are made a lot easier by model specification using Fornilab. And so that's also the thing with MATLAB. You could implement all of the math in MATLAB, and that works out fine. But there is not, at the moment, there isn't a general software package in MATLAB for probabilistic programming. MATLAB tends to lag a bit behind, but once they do develop a toolbox, which is also sold, of course, it tends to be quite robust. So yeah, you will be able to download MATLAB and then install the toolbox, and then it tends to run nicely. So maybe in a couple of years you can do the same in MATLAB.
All right, I was just curious about the MATLAB. Thank you for your answer.
Yeah, you're welcome. Right, so we're getting a bit more interaction in the chat. Let me just finish the answer on broadcasting for a moment. So here I've defined the vector x, and now if I want to so you'll see here that I'm able to multiply a scalar with this vector. If I now make this into a matrix, and note that I need to remove the commas for that, then scalar times a matrix works. If I now take this is dot product, this will also, hold on, yeah. This will also work. If I want to multiply each row with each of these elements, then I can broadcast this operation. You see that the first row is multiplied by, of the element in the first row is multiplied by 1, 2 is multiplied by 2, and 3 is multiplied by 3. Then 4 is multiplied by 1, 5 is multiplied by 2, and 6 is multiplied by 3. So technically this is not a valid linear algebra operation, but it's a shorthand notation to do something for each or for every. So it's instead of having to define for loops where I loop over rows, and then for every row I do for every element multiply with the corresponding element in the thing that I want to multiply with. It gets very complex, and sometimes things are just it's clear mathematically or conceptually what needs to be done, and you don't want very messy code to perform that thing. So these points are there to tell Julia that you want to broadcast your operation, that you want to do something for each. They're very contextual, so it works certain ways in certain contexts. But often, at least I try to keep this context clear in these notebooks. So here, for instance, I've defined a range of theta values. So that means that theta runs from 0 to 1, and then there's a step side of 0.01. So that's a lot of numbers for theta. And so I want to compute the probability density of theta using this distribution. And so by adding this point here, I can compute the probability density of every theta in this range, which is what I'm plotting here. If I would not do this, then it would try to compute the probability for all of the thetas combined, and that's not a valid operation under this probability density. So it's going to give you an error. But you see, so it is contextual, these dots, and it takes some time getting used to, and then you need some practice with this. But once you do get some practice, you'll be very happy that this exists, such as here. This is a nice example where I think the context is clear. Right, so let me get back to public chat. Let's see. So Tim just specifies the dots can confuse me. Tudor, you already asked the question, especially to use alpha, beta variables. Yeah, okay. Willem, what's the goal of this session? So in this session, so I'm assuming that you've seen the lecture notes, or that if you go to this website, blmp.nl, so here you can find the lecture notes. I'm assuming that you've read this and that you've watched the videos on Probabilistic Programming 1. So that's W1, W2, 1.1, 1.2, 1.3. So that's all of these. But I can imagine, because this is a new programming language, a new working environment, and there's all this math, that there are still things that are unclear. So you're allowed to ask questions about how we do certain things. You're also allowed to ask questions on code. If I can answer them quickly, I will. If we're getting a backlog of people who want to ask questions, then I'll defer things to Piazza, and we can talk about it there later on. Tim said, check the tab title of the page. It's a Sandloper. Oh yeah, so that's for the earlier problem on not running. Yeah. So the point is that a lot of people watch this so that you only have to explain something once. That's troubleshooting. Could you please tell us how precisely you ran the folder during the download editing, or is it over the web page? I used binder and execute, so I did something different. Right, so Magnus, you already answered this. So Cornelia, are you familiar with Git? So Git as a tool, so basically you download something, and then whenever something changes online, you can perform an action called git pull, and then it updates your local version to the online version. So Git is usually used in software development context, and there you can update your the files that other people have been working on and pushed online. You can get those in quite quickly. If you're unfamiliar with Git, yes, you have to download the package and then unzip it and then work from there. This is not a course on Git, so if you're already familiar with Git, just use your standard workflow. If you're not, then do the download thing. And it's described in this first video on so I explained at the end of the last lecture, the one by Bert, that we have a Julia and Jupyter install guide. And here is a video with step-by-step instructions on how to install everything and also open your Jupyter notebook environment. Let's see. Yeah, so there's a command, you change your directory to the one where you downloaded the GitHub files. Then you run Jupyter Notebook, and then you get this thing popping up, and then you can explore this for the Probabilistic Programming notebooks. Right, so that brings us some claims. Yeah. Could you finish answering the question? Yeah. Done that. Recommend steps to configure Jupyter, run iJulia. Willem, you said, why would you want that? Yeah, so I'm sorry, I'm a bit behind on comments. What are you referring to? Why would you want that? Yeah, Magnus also helps. Yeah, model for Julia, that's true. Yeah, so in general, Julia moves a bit faster than Python because it started, and then it's a small user base, you can make more changes. It's becoming a lot more mature at the moment. The main advantage of Julia over Python is that Julia has a few new things that have been invented and popularized in the last 10-20 years, and Python has basically become so big that it can't change, it can't adopt those new features. One is called multiple dispatch, which means that you can write the same function. For each function, you can specify an input type. And so when I call a function with an integer, for instance, it defers to the function with integer input argument. And when I call that function with a float number, it refers to another function with that float. So that means that you don't have to write the same function and then check what kind of input argument type you're getting, but you can just write two different functions for two different cases. It doesn't sound like a big deal, but in practice, in a lot of software development settings, this matters a lot. Julia also allows you to work with Unicode natively, so you can type Greek letters, you can type emoticons as variables, which is often one of the most visual features of Julia's thing. But if you're interested, Julia's website has a lot of descriptions on what makes it different from Python. And we believe that Julia will be the next big machine learning language. So that's why we work with it. Bart Verboeken, when handing in the assignment, does the workspace folder also have to be handed in or only the notebook? It's fine to only hand in the notebook, but do make sure that you follow the submission instructions. So some people already found the notebook assignment, some people have already found the assignment on Canvas. Right, so it's on the files, Probabilistic Programming assignments, and there's PP1 assignment. But I had not yet opened the first Probabilistic Programming assignment. So that has been opened this morning. This has a description for what you should do when you download this file, what you should do in the notebook, and then how you should submit the notebook. So I will auto-grade the notebooks, and in order to ensure that this auto-grading process goes by smoothly, I need you to format the submission in a particular way. So if you don't do that, then either I have to do everything myself, or there's a chance that things break, or so there's a chance you won't get any score. You won't get a score for your submission. So what you should do is you'll have that notebook where you've entered your own code. Put that in a folder called Prog1, Prog1, and then put that in a folder with your student ID, and then zip that folder hierarchy and send the zip. For the next assignment, we'll create a zip category with your student ID, and then Prog2, and then your name, and then your notebook, I'm sorry. So at the end of the course, when I've received all of the notebooks from everyone, there'll just be an ID, and there will be Prog 1, 2, 3, and 4, and then each of those contains a notebook, and each of these just contains a notebook.
Just a small question. Are we going to go through the the answers or like the solution of the assignment after we've handed it in?
Depends on if you want. So during these sessions is a flipped classroom, the Q&A. If you want me to talk about the solutions to those answers, we can do that, provided that the session is not fully booked with other questions. I was also planning on just releasing the versions with the original code in there, because so I write a notebook, and then there's a block where your answer here, and then I have a thing that hides my code and then transforms it into your code here. So I can publish those, and then you can see what the notebook or my version of the notebook looked like. Basically what I wanted you to program.
Okay,
so
great.
Yeah, okay. Cornelia, so similar to the dot in MATLAB, yes, although the dot in MATLAB is mostly for algebraic operations, in Julia you can use it for a lot of things. So as you just saw, I can apply a function to each element in an array. And I think there's something in MATLAB called basics fun that allows you to also apply an element-wise operation. yeah, so you have to do basics fun and then the function and then 2 arguments or 3 arguments, something like basics fun minus at the dot operation in Julia allows you to. It also has this functionality, but it's more contextual, such as we saw in the PDF dot example. This one's a bit more explicit on what you're doing, that you're broadcasting something. Yeah. All right, that was already there. Yeah. You don't have to add the workspace into the folder. It doesn't matter. With the autograder, just looks at your notebook. So I put the workspace in there so that when you run the notebook, you have access to the workspace. It's exactly the same workspace as in the main files on GitHub. Yeah, so the autograder will ignore the workspace directory. Phone using alpha encode is a feature of Julia or Jupyter. It's a feature of Julia. So I can press alpha and tab and it will give me alpha. Yeah, it is for Julia. In Jupyter, it is possible to do this. There is a package, something called Unicode something. I haven't worked with it, so I actually don't know how it works. But I've heard that there is a package in Python that allows you to do this as well. Yeah, it's a bit more complicated. In Julia, it's really nice to do this because Julia is also used a lot for scientific programming. So when you have an equation, some differential equation or some crazy thing with lots of special notation, then you can just use that special notation. If you're able to write it in LaTeX, you're able to write it in Julia. Yeah, so if you open a Julia terminal, right, so that's not visible here, so I have to reshare my screen. Oh, no, that's the wrong one.
Hi everyone, I'm back. I had a short failure. Hi. Let me open the notebook. Yeah, so I was at this question. Yes, if you open a Julia terminal, you can straight away do /alpha tab, and it completes it into an alpha character. You can also use it in a .jl file. Yes, that's true. Bram says, just FYI, the link in the PropBook one for the course installation guide still links to the old guide. But we updated the file, so the file should no longer exist. Oh, wow. All right, that's a... Hold on, I'll show you on my screen. Yeah, you're absolutely right, Bram. If you press this link, this takes you to the old PDF. I did not know that we still had the old PDF in the thing. I will fix this later. Yeah, so please, to anyone that's listening, if you have not installed everything yet and still have to, please use this link, Julia and Jupyter install guide. It contains the up-to-date PDF, November 2nd, 2020, with all of these versions. It still contains 1.5.2, but Julia updated to 1.5.3 November 9th, a week later. Don't worry about it. Both 1.5.2 and 1.5.3 work. Yeah. Yeah. Yeah, so as Bert said, I got thrown out the video call. Yeah. That happens. Any more questions on Probabilistic Programming 1? Have you all tried playing around with these distributions? If you've managed to complete the notebook, could you just type yes in chat? Then I have some idea whether... Yeah, okay. All right. That's good to hear. So I see Willem is typing. I'll wait for that. And then after that, if there aren't any more questions, then I'll quickly show the first assignment, and then we'll call it a day. Willem says, I think you might already have discussed it, but while my Jupyter and multiple libs show up in the conda list, I get syntax error running the programming 0 notebook. Right, so if that first assertion fails, that you're on 1.5.2. Oh, right, yeah. Okay, so Probabilistic Programming 0 checks for whether your version is 1.5.2, and so if you download the 1.5.3, yeah, just change it. At the assert version is v 1.5.3. After that, it should run nicely, as some says. Yeah. All right. Then I will quickly show. Yeah, exactly. All right. So this is the first assignment. So as I mentioned in the assignment description, this is a notebook. This notebook, you will be able to do something. In some of the cells, most of the cells you cannot change. I've done this to make sure that you cannot, by accident, disrupt the supporting workflow, essentially, the supporting code. Some cells contain hidden assertions. I'm not going to describe how they're hidden. And so when you submit the notebook, I can run the notebook and it decrypts what these cells says, and then I get a score for your notebook. So please, in some cells, you'll find the comment, your code here. Your job is to program something here yourself. You have to remove this error bar, otherwise it's going to give you an error. And then, so once you program something here, and you remove the error, and you do that everywhere where you find this piece of this comment, this piece of code, and the entire notebook runs, then you're ready to submit the assignment. Again, if you get some problems with that, if you're stuck somewhere, just post something on Piazza. Have I said it? Yeah. Okay. So, right. So if you think you're done and everything runs, make sure to restart the kernel. So sometimes it keeps a variable in memory that you haven't that you've removed from one cell, but it might still be in your workspace, even though it's not, your workspace is not shown here. So restart the kernel. Go to kernel restart, and then run all cells. So cell run all. If you do this and it runs everything nicely, then you're ready to submit. Make sure to enter your name and idea in this first bar, so I can backtrace from what this notebook, who wrote this notebook. So the first assignment relates to the first probabilistic programming session. It's specifically about this likelihood function, because I think that's one of the most difficult concepts in the first session. So we'll start by activating a workspace. We'll call a plot library. You'll be given a very small data set, again a range for the theta parameters, and then a likelihood function which we compute manually here. That plots something, and then your job is to compute the likelihood of a specific value of theta using this supporting code. So you have to answer that here. You create a variable answer1, then it prints out this answer1, which means that if you don't create a variable with answer1, you're already going to get an error in this cell. Later on, this cell checks whether your answer1 is actually a float, because the format of the answer should be a float. And there's a few hidden tests here as well. Then we're going to add data, namely these three observations, to your data set, and then you're going to recompute the likelihood. Again, you'll have to do that here. It checks for an answer2 variable, and then checks whether that answer2 is a float. Moving on, we'll add even more data, and then we'll then I ask you which is larger, the likelihood of theta 0.5 or theta 0.8. You'll have to create a variable called answer3 with either 0.5 or 0.8, and then we check that. And then there's a final reminder to make sure to restart the kernel and run the notebook before you submit it. Let me see whether there's any more. Willem, you're getting that using package is invalid syntax? Yeah, suppose that on Piazza. That's highly unusual. Oh, you got it. Okay. Yeah. Okay. Right. So if there aren't any more questions, then I'm calling it a day for today. So just as a reminder, the probabilistic programming assignments are not mandatory. They're just there to see if you can, whether you've understood all of the stuff that we talked about during the probabilistic programming sessions. Another reminder, the probabilistic programming sessions are not new material. They're just there for you to get your hands dirty and get an intuition on some of the theoretical concepts that Bert discusses. Is there anything else I should say? Yeah, I hope they're fun. They're going to ramp up a bit more in difficulty. The first one is just the first one's very descriptive, a lot of text and a lot of visualizations. The other ones will also have a lot of visualizations, but they'll be a bit more difficult. But it's important to get to understand this concept of a likelihood of prior and a posterior before we move on to more complicated models. At the end, we'll be doing Kalman filters and Gaussian mixture models, regression classification, all of that. So look forward to that. I'm pretty sure it'll be a lot of fun. Right, so Buku is still typing something. I'll wait for that. When was the assignment getting graded? When it closes, take a few minutes after handing in. Yeah, so I'm going to close the assignment submission before the next probabilistic programming session. So that's in 2 weeks on the 4th of December, I think. Yeah. The 4th of December. So in the morning of the 4th of December, I will close the submission. I then have to collect all of the submitted files and then run the autograder. So it might be that I have all of your grades during that session. If something goes wrong, so if I see that a lot of zero scores and I think there's something suspicious happening because something went wrong somewhere, then I'll take a bit more time to grade everything, to double check whether everything went well. Wendy is typing something. I'll wait for that. You just mentioned prior posterior understanding is an important aspect of this lecture. Is it true that these are not relevant in assignment 1, or am I doing something wrong? These are not relevant in assignment 1. So in this assignment, we are just zooming in on the likelihood function. But the probabilistic programming session does contain the prior and posterior. We do have an extensive bit on the prior distribution, on the beta. You can play around with the shape of the beta. You can see they get all sorts of, it's very flexible. And I hope that ties back into your idea of maybe you have some preconceived notions of whether you can taste alcoholic from, or discriminate alcoholic from non-alcoholic beer. So I challenge you to try this out for yourself. Describe your prior knowledge or your current knowledge of how well you think people can discriminate this using a beta distribution. And the posterior, so we have a lot of data in this very simple model. So we show posterior estimation, but it will actually follow the likelihood quite nicely. And then for this specific case, if you plot both the mean of the posterior and the maximum of the posterior, that shows you there's a slight difference between these 2 point estimates. I hope that also it gives you a visual example of what the difference is between inferring a full posterior distribution and a point estimate. So a posterior distribution describes the probability of every possible value of the parameter, and a point estimate just describes that one particular value for the parameter was either most probable or expected, or All right, then I'm calling it. Have fun with the assignment. We'll see you all on Piazza. For those of you who are still stuck and having trouble, we'll continue to support getting everything installed. There are backup solutions, as I said in the beginning of the lecture. We'll get it up and running. Don't worry about it. And so outside of that, I'll see you all next week at Bert's lecture on Wednesday.